Okay, so during the break I noticed, I took a look at the board and I did an inspection of all the pins. And I noticed two pins that didn't really get enough solder, and those were two that I couldn't see very well because I didn't want to move the board around too much. So I'm going to fix those up real quick. And it was one side of the diode and then one side of one of the 47 microfarad capacitors. I'm just going to take a little drop of solder here and reflow the diode. And then this side of this cap just didn't get enough solder. That looks good. Alright, so get back to it. So the next step, I think I'm going to solder on the rest of the small 0805 parts. Looks like we've got 5 more, and then the fuse as well. So I'm going to put some flux down on C10, C4, R6, C8, and F as in fuse 1, and solder those parts on. Start with the fuse. None of these parts are polarized, so they can be soldered on any direction. If the part has text, I try to keep the text all facing the same way, but it doesn't really matter. This fuse is called a PTC. I don't actually remember what it stands for, but it's a temperature-based fuse, and it automatically resets itself. So if this thing tries to carry more than 500 milliamps, it stops the flow of current until the current has dropped back down, and then it automatically resets itself. Some of these are a little tricky to get to without moving the vise, so give it another shot here. So that's the fuse. And next up, we finish up the rest of the 100 nanofarad capacitors. So looking at our sheet, we've got C8. Let's see, C10 is 100. C4 is 100. I think actually the rest of the caps are 100 nanofarad. So grab those out of our parts box. Oh, just found that resistor we lost at the beginning of the video, hiding in the parts box. So I've got my 300 nanofarad capacitors here. Just put those where they belong. C10, C4, and C8. Those 3 are soldered. So we've got R6 is left, and I think that's it for the small components. So R6 is a 4.7K. Dig that out of the parts box here. It's kind of stuck. I don't think I mentioned it before, but these 4.7K resistors are marked 472. So that goes on R6. I see we've gotten to the weird part of this Boards of Canada album too. So that's the rest of the small components. So now we're down to the big guys. The first one I'll do is the power connector, which is J1. And it looks like I didn't even bother to label it on the board. Unfortunately, the hole to the left of the power connector is a little too small for the little stud that sticks out the bottom of the power connector. So I just use a little razor knife on this back stud here just to trim it down a little tiny bit to fit in there. You can even just force it into the hole, but this is a little cleaner to do. So just trim that down in a square. And try not to cut it off completely. So we'll just check that first before we solder anything. And you just want to set it down and make sure that the studs go through and that the metal connectors on the power connector sit flush against the board. So it looks pretty good. So lay down some flux on those large pads. And set our connector in there. And take a second to align this. Make sure it's nice and square with the board. You don't want your power adapter to look funky when it goes in. And again, since this is using such large pads, I go back to my old Radio Shack solder. You can use pretty much anything, but that works for me. And on this one, you want to get a little ball of solder on your iron and get one of the pads. Get a little bit of solder on one of the pads just to hold the thing still. These pins are so large that, similar to the MOSFET and the voltage regulator, they kind of heat sink your iron, so they may take a little longer for the solder to wick than some of the smaller components. Once you've got one down, just feed plenty of solder and get the rest. You want the solder to flow up and over top the pin. You want this to have a real strong physical connection so that inserting and removing the power connector doesn't break it free from the board. So use plenty of solder. Just ball it up on there pretty good. So that's on there. The next one we'll do is the real-time clock. And that's IC4 at the bottom of the board. So we're going to flux all the pins, or all the pads for that chip first. And you flux. And this one's a little tricky to position, so blow on the flux and let it get sticky a little bit. Alright. And pin 1 is marked on the chip, and it's also marked on the board, so just make sure those are lined up. And we'll just line this up nice and even with all the pads. Looks pretty good. And then, just like our processor, get a little solder on your tip and just pin one leg down to hold the thing still. just takes a second. And then once you've got one down, hit the one caddy corner to it. Make sure the chip is held down nice and solid, and then just like the other, just takes a little half-second tap on each pin to solder it up. These leads are actually pretty big, so it's you can move quick, and it's tough to make a bridge on this guy. Alright, that looks good. So the last chip that we have is IC2, which is the actual driver for the tube. And this and the clock chip that we just did are the two expensive chips. These are the two that you don't want to screw up. Usually when I'm making one of these boards at this point, I would actually take the board out of the vise and program the processor and do a series of tests just to make sure that everything's working before I solder on these last two chips. That's just to make sure that I haven't made any mistakes that I can't fix, and if I'm gonna have to throw away the board, I would rather throw it away without the $20 worth of chips on it. This one's gone pretty smooth. I don't see any reason it shouldn't work just fine, so I'm gonna skip the testing and just go on with the soldering. So flux up all the pads on IC2. And like the last one, we're going to let this one dry for a second and get sticky. Out of all the chips, this one is the most static sensitive, so I don't work in a very ESD safe area. I do have a pad down, but I don't really worry about it too much. I don't think I've ever shocked a chip. Maybe that's just luck. So let's get this pretty well aligned. These pins are actually pretty big too, like the last one, so not too hard to line up. And by now, this should be pretty familiar. You can use any pin that you want to start the thing off. I try to pick one that's easy to get to. I picked that one because there is capacitor near the bottom leg, so save that for last when it's already held down. Once we've got those legs held down pretty well, we can just finish up the rest of these pins. This is going to be a little tricky to do without turning the vise, so I'm going to turn that around real quick. My vice jaw is a little too tall here, so I'm bumping against it. I'm trying to get these last 2 pins. There we go. Turn that back. Okay. So the last surface mount component is the battery holder. For this one, we have to add a pad, which is where the battery makes its negative content. So what we're talking about is this pad right here. And all we want to do is just put a little dome of solder on that pad, just enough basically to keep the battery from touching the circuit board. Doesn't take very much. I'm using my thicker solder for this. It does take more than an 0805, but not a whole lot. So actually I forgot to flux that pad. And you kind of see what happens if you don't use flux. The solder just balls up on the metal. It doesn't want to stay. And I'm going to go ahead and flux the other 2 pads while I'm at it for the battery holder. So we're just going to apply a little bit of solder, a blob, and then just use the soldering iron, kind of smear it back and forth until you have a nice evenly shaped dome. It should fill the square pretty easily. It's not too tough. You can kind of see what that does. And doesn't take much. What you want to do is move your soldering iron to the very center before you pull it away, and that'll leave the dome with a high point in the center. I'm going to take a quick peek at that with my loop and make sure it's tall enough. Probably stand a little tiny bit more. There we go. Looks good. It's just a couple thousandths of an inch high, just enough to keep the battery from touching the circuit board. So our last surface mount component is the battery holder, and just slide that right over. Get it lined up on the 2 large pads. The alignment's not too important on this one. You want the flux to be sticky at this point because this one's a little tricky to solder. The battery holder has 2 little holes through the pins, and the best way that I found to solder this thing is to get some solder on top of those holes and let it get nice and hot, and it will flow under the connector, and then as you pull your soldering tip away, it will actually form a ball on top of that hole, which holds it down nice and secure. So I'll try to demonstrate that without moving the part too much. So I'm going to get a little bit of solder on the tip here to get things going, and just dip that down in there. And right now I've just got a tiny bit peeking through that hole, and that's going to hold it still. Do the other side just so I can get both sides locked down. So I've got a ball on top of that. I'm going to add a little more solder to this other side now. Just make sure you get plenty right on top there, and that it bonds with the metal. You see the solder color change as it starts to bond. That looks pretty good. That thing soaks up quite a bit of heat, so let that sit for a second. It's still pretty hot. And just give it a nudge with your finger, make sure it's on there good and tight. It takes a decent amount of force to get the battery in there the first time, and you don't want that to pull off, or even worse, to pull a pad off, which would ruin the board. So that's it for the surface mount. The parts that we have left are our rotary encoder, which we'll pop in right now just to show where that goes. That piece goes in, and that just snaps in like that. We solder that from the other side. And then the final part is the tube itself, which comes in from the other side. That's going to be a whole separate video because it's a real pain. At this point, pop your board out of your vise, inspect all your connections, check for bridges, check for any kind of problems that you have, any shorts, any bridges, any pads that didn't get enough solder, and then plug in your power supply and your programmer, and you can actually program the board. Note that the pins for the ICSP and the EXP jumpers, if you look at them close, they're kind of offset and weird looking, and that's done so that you can actually insert these little jumper pins like this. They don't actually have to be soldered in. You can just set them in there and push them in, and the offset pins cause them to kind of lock in. So you can actually program the board and then pull those back out if you don't want to keep them in there. That's it. Good luck.